This is a video about QuadTrees, client-side prediction, and entity interpolation. These are three tricks I've been learning about lately that I think can help to make an MMO. I'm not really trying to make an MMO, but I've always wondered how people make MMOs, how you can get that many players connected to a server, have consistent experience throughout. So in my free time, I've been studying some of the code techniques that are involved in getting that many players connected. One of the first things I've always wanted to learn, just because I've seen fun demos of them on the internet, are about QuadTrees. Here's a QuadTree right here. QuadTree is a data structure that lets you subdivide space to store things in it. So these dots or circles here are existing in this QuadTree, which is currently divided into 4 squares, which I think you can vaguely make that out. We'll see how this video comes out. And the trick is, if you want to perform some sort of collision check on these, normally it could be pretty intense for the computer to check this many moving objects against each other. But using the QuadTree, when these objects start to check, they only have to look in the square that they're in. So you can make a QuadTree that divides down to very small squares, and hopefully when any given object is asked to check if there's anything around it, it'll be there in a little node alone, and it can easily answer that question, because if it's alone there's nothing to hit, or if there's one other object it only has to see if it's touching that one other object as opposed to checking everything else on the screen. In any case, I've got some code for that, and I was just going to go through making the QuadTree subdivide a little bit more, so we can just see how much work the computer doesn't have to do thanks to using the QuadTree. So here the QuadTree is divided into 4 pieces. The little circles are being generated procedurally very quickly, so the exact number is changing. But I'm going to change this QuadTree to make it so that it can't subdivide, so we can get a count as to see how many are actually fitting in the screen altogether. So here it is, not subdividing. You can see it's just one square, and the number I'm reading in the center, very small and hard to read, it's fluctuating around 730. So there's 730 of these little circles in there at any given moment, and each one is being checked against every other circle to see if it's touching it, which is a lot of calculations. There's also a mouse over effect I made, where the mouse has this square attached to it, and anything it hits will become colorful. So that's just another check to see if we can check for collisions in a fast, live way, as fast as I can move the mouse. In any case, I'm reading from the scrolling console down below, and at any given frame, it's doing about 400 to 450,000 calculations or checks to see if any one of these things is colliding. Now, the goal of the QuadTree is to subdivide the space and thus reduce the number of things that have to be checked. And I'm going to do that right now so we can see how much the calculations change. So the peak around here is about 450,000. So I'm going to let the QuadTree divide a little bit by changing something here in the code. Let's see if that's enough. I don't think that's enough. I'll make this number a little smaller. Let the QuadTree divide hopefully into 4. So here it's definitely dividing to 4. Now it's checking pretty much the same number of circles. It's gone from doing 450,000 calculations 60 times a second to 130,000 calculations. So hugely easier for the computer already. But it could be better. I'm going to let it subdivide even more down to squares that are as small as 50 possible pixels. Let's see here. So now it's been cut up yet again for it to perform the same math. Here it's now down to, it's fluctuating, but it's about 40,000 calculations. So here it's already a tenth of what it was in the first case. It's also now taking 2 milliseconds per frame. These frames it's rendering at something that's very smooth, 60 frames per second, to keep up with 60 frames a second, I believe you need 16 milliseconds. So if you can finish your calculation in less than 16 milliseconds, you have no lag. And this has no lag. Let me cut this number down some more, let this thing subdivide even more. So there, they're getting pretty small, these little parts of the tree. It's now taking 13,000 calculations, or it's saying 13,000 potential collisions are evaluated in 2 milliseconds. That's approximately what it's scrolling down there in the text. Let it go even smaller. I don't think it's going to improve too much. I haven't figured out why exactly, but there appears to be a sweet spot between doing too much work subdividing the quad tree versus doing too much work looking to see what's collided inside the quad tree. So here it's down to 4,500 potential collisions, which is a lot less to think about than the initial, I believe it was 450,000. However, it's not actually running as fast as it was just a second ago probably because of how much it has to subdivide the quad tree. It's now taking about 5 milliseconds a frame, or 5 milliseconds per calculation, and I believe when the quad tree was not quite so small, when it was this size, it was a lot less. Yeah, so here it's about twice as fast. So I don't know why there's a sweet spot there, but there certainly is. In any case, I wanted to use QuadTrees in my quest to make an MMO because I thought the quad tree was a data structure that would speak to scalability and dealing with a massive number of players, or not even players, just like NPCs in the MMO. I thought, how do we answer the question of which NPC is close enough to a player that you need to know if they're colliding or if they can see each other, if they can interact with each other. And I thought the quad tree was one of the data structures that could answer that question for me, and it would be performant enough that we could really think about having a whole ton of people connected to one server. The other thing I'm using the quad tree for, and I'm going to talk about it now while this little quad tree demo is open, because when I get to the actual game itself, the quad tree, it's just behind the scenes logic. There's nothing to look at per se. What I wanted to use the quad tree for was I wanted to be able to subdivide the MMO world, and in any given space, I want to know what its population is. This is the exact question that this quad tree itself, has to answer before it knows how to subdivide itself. It subdivides itself by saying, am I too crowded in any given area? If I am, I'm going to break apart and distribute all my little objects, or in this case these circles, across into smaller nodes so that the calculations get easier or whatever. In any case, part of the quad tree is what the population of any area is. And I figured if I had that information, I could make it so in a server, if it's too crowded in one area, the server will send less data to those people. It'll begin to deliberately lag them in an effort to just not crash from being over encumbered. So now I'm going to go on to the actual little game itself, which is not really a game. I mean, game's really an overstatement. Let's see. I've programmed it in Node, which I'm just going to start my little Node server here, which looks like basically nothing. Just it's little scrolling 0 milliseconds to tell me it's not lagging, and it'll write some other things when I connect some players. The client for the game, what you use to connect to the game, is it's a browser game. So it's HTML5, it's rendered into Canvas, and I'm going to connect a player here now. So the game used to be entirely just squares sliding around on this canvas, but I've been drawing a little, so I added a little sprite animation to make it, a little more bearable. And so that you can actually perceive movement, I've put in this procedurally generated, although ugly, green background. So here's what the game looks like. And the two next things I wanted to talk about were the tricks for smoothing over lag, enabling the server to send out less frequent updates but keep it so that the players still have a good experience playing the game. These two tricks are client-side prediction and entity interpolation. Client-side prediction, which I learned about almost entirely through reading one of those Valve articles about how it works in the source engine, is the trick of letting you move before the server has had time to reply to you and tell you about your movements. So here I have one player connected alone. Client-side prediction's on, which means the player here is moving, and it's moving instantaneously before the server has confirmed whether the client can actually move there. I've made these two gray squares here, and even though you can see them rendered on the client, the trick with these gray squares is the client acts as though it's totally ignorant of them. So when it collides with them, the client doesn't know it's going to hit them. It actually has to tell the server, and then the server will inform it after it hits it that, oh, you weren't allowed to walk there. So these two gray squares are what I use to basically deliberately cause an error where the server and client are going to have a different opinion, so I can work out what to do in that case, which is a common case. So with the client-side prediction on, you'll see I drew a little square at the foot of this little guy so you can see exactly where the collisions are being calculated. With client-side prediction on, I can step just a little bit into the wall here. This is because the client I've made deliberately ignorant to this square, so I can move into it. I can't make it that far into it because the server is replying before I can make it too far, and it's saying, you know, you've collided with something. You can't go any further. Now, I'm going to turn off the client-side prediction, and we're just going to move around. My animation stops because my animation was linked to my prediction, which is no longer occurring. So now this movement is the real movement. When I hit the key, it does not start moving the character. It instead goes to the server. The server says, okay, you're moving. The server moves me, and the server then replies and tells me that I've moved, and then I render it. So given that my server and client are here on the same computer, there's not a whole lot of lag. In fact, I think I calculated there's 50 to 100 milliseconds of lag. So it's pretty instantaneous. However, I'm going to produce some lag because I'm going to connect a bunch of players here, and going back to my quad tree, we'll get to one of my tricks to throttle bandwidth, which is going to deliberately create lag, and we'll get to see a different case. In any case, I'm going to start connecting some players. So how I connect multiple players here is very unsophisticated. I open more tabs, I add more players, and I move them all around manually. So I'm going to connect a few here. So we got 3 players. Now, one of the things I did, which I haven't mentioned yet, is I use the QuadTrees behind the scenes to tell if a player is near another player. I do this for the sake of having the server know who needs data about who. And for the sake of this demo, I didn't make the size of the area around which you receive data. I didn't make it full screen. I made it much smaller than the full screen, so that I could see, you know, I could confirm visually that as I move away from these players, I stop receiving data about them. And the flag for that in the interfaces, they turn red. A player will turn red when you stop receiving data about it. So here I am moving around this gray guy, and you'll see he's got a pretty small box around him of area where he'll receive data. So I'm going to move away from the green player over there on the left, and we'll see right around here I'm too far away, and I'm no longer going to receive data. Now normally one wouldn't do this in game, one would make it so it's, you know, past the edges of the screen, so you never would see this. But for the demo, there it is. That's where I stop receiving data, and then if I move up away from, I don't know what color this guy is, they're all randomly generated. I guess he's brownish. Right around here I stop receiving data about him, and here I'm receiving data about neither of them. So that's part of the quad tree trick, and the other part of the quad tree was my my idea about population. If it gets dense, we're going to throttle how much bandwidth goes to these players. So I'm going to connect a whole bunch of players here, enough that we're going to get to my rule, which is throttle the bandwidth when it's too crowded, and then we're going to see the changes that occur in the client-side prediction, namely that the updates become less frequent and the collision doesn't work quite as well. So one of my first rules was if you hit, I think it was 4 or 5 players all right near each other, I'll try and get them near this box because I have to collide with it, throttle their bandwidth so that the server can handle lots of connected players. We'll see some red flickering perhaps when we hit enough players. The red represents that you're not receiving data. It can be because they're not close enough to you for you to get data, or it can be because the server's deciding to cut out some of the data for its own sake. So here I'm seeing some flickering. So I think we're certainly into that case where the server's turned down how much data it's sending. So now we're going to move around, client-side prediction still, and we're going to try and collide with this gray square again. We'll see that I'm not sure if I see it. Oh, no, I guess it is different. Before I was making about 1 pixel into this thing, now I'm sliding quite a bit further into it. So that's one of the differences. Now, you'll see that the gameplay is actually still perfectly fine. It's fine because of the client-side prediction. And we'll see now that we've hit enough players that we're operating at a different rate, if I turn off client-side prediction, which I'm going to do, it'll become obvious. So you'll see my movement now is choppy. This is the actual movement coming from the server. And yet, with the wonders of client-side prediction via that Valve article, we turn that on, and same amount of data right now, perfectly smooth and playable, looks nice to you. If it wasn't for this red flashing stuff that I deliberately programmed in here, we wouldn't even know that there was any kind of issue. The other trick is the entity interpolation. The client-side prediction is for your own experience, for you having instant feedback. The entity interpolation is for you seeing everyone else smooth despite not having a whole lot of data about them. So to show that, I guess I'm going to have to split these windows apart. We can cover up the server over there because, well, it doesn't do anything. Nothing visual, at least. So here we've got 2 windows. So I'm going to move here on the left window, and you're going to see it in both. You see me moving, I guess he's blue, around. You can see when I walk away, too far away, you know, I just start running in place. That's because I moved away from whoever it is on that right window, which I'm not actually sure. So the entity interpolation is a smoothing that's applied to this blue guy who's moving around. If I turn it off, I'll turn it off on the right screen. See who is on the right. I'll move him around a little bit. Okay, it's this guy over here on the left. I'll give him a name. Hey, it's me. Or just hey. So the guy named Hey over there, that's whose eyes we're using. So now I'm going to move blue around, and Hey has entity interpolation off. So we'll see what he sees from blue now is this, well, blue's this choppy, moving thing. This is the real data that you receive about the blue player. And with entity interpolation, which I think I also got from Valve, is that true? Yeah, it is. It was there was a few tricks to entity interpolation. One was an article which I'll put in the comments for this video, and another was the source article on it. It smooths it over, so we'll turn it back on here as I'm moving. Let's see. Oh, I didn't click it. So now it's moving. This is even it's pretty smooth. And this is even in the case where the bandwidth is throttled down because things are too close together. If we move, I'm going to take blue over here, and I'm going to move him away from everybody. And then I'm going to take Hey, which is green, and we're going to go find blue. These guys are now far enough away from everybody that they're no longer throttled, and you see perfectly smooth movement here. I think even with the entity interpolation off, we'll see pretty smooth. But it's not that smooth. It really still needs the entity interpolation to be smooth. In any case, those were the 2 tricks. Or sorry, I should explain entity interpolation a little bit. Whereas client-side prediction was about using your own inputs and applying them immediately, as opposed to waiting for the server. Entity interpolation is different. It's about getting information about where the players were and saving it. And then to make a smooth animation, rather than doing any kind of prediction or extrapolations, you simply wait till you have enough data that you can show them moving between 2 points. Which means that inherently when you're interpolating, anything you see is actually occurring in the past. You actually waited for them to already move, and then you start to draw between the 2 last known positions of the player. However, even when the game starts to slow down, and I've tested it at a variety of different delays, be it 50 milliseconds, 200 milliseconds, even a full second, it still looks pretty good. And the only times where it gets to being a full second, at least in this engine, is when there's like 30 players on the same screen, and it's just at that point I'm just amazed it's even on. It's still working, not crashed. So I've been pretty happy with these techniques. I don't think I'm really going to make an MMO out of it, but I am going to keep experimenting with it, keep trying to see how many players I can get connected. So far I've gotten 300 connected via opening just 300 Chrome tabs, although I'm pretty skeptical that Chrome was actually sending the data from all those tabs, especially since they're in the background, and I know Chrome will do some things to throttle what's occurring in the tabs that it doesn't need to show you anything for. But I think as I move forward and write some bots to connect to the server so I don't have to open a million tabs, we'll find out what the actual number is, and I'm hoping it'll be high. In any case, that's all I've got for now, and as I continue with this overly grandiose project, I will update it on my blog, which is also going to be in the description for the video. Thanks for watching.